In this video lesson, we are going to explore the concept of percent composition in compounds. We'll start with the definition. The definition of percent composition is the percentage by mass of the elements in a compound. The equation is the percent of the element is equal to the mass of the element over the mass of the compound. And then the whole thing gets multiplied by 100 to put it into percent form. Let's take a look at a couple of examples. This first example type is mass data will be given of either the elements or the compounds that are formed from the elements. What's not given is the chemical formula is not given. So the chemical formula is not given in these problems. So for example, we have a compound containing only 222.6 grams of sodium and 77.4 grams of oxygen. Calculate the percent composition of the elements in this compound. So what we need to know, what we need to recognize is that when you have an element and an element forming a compound, it's pretty simple to, by the law of conservation of mass, we know that the first element was sodium, right? And so that was 222.6 grams. That was for the sodium. And the other element was oxygen, so 77.4 grams, that's oxygen. So we know that the mass of the two of those combined, if we work that out in our calculator, right, so we're going to get 222.6 plus 77.4. Maintaining sig figs, we get a mass of 300.0 grams for the mass of the compound. And once we have all those numbers, we are all set to actually do this calculation. So best practice is to make a separate line for the percent sodium and the percent oxygen. So the percent sodium would be the mass of the sodium, 222.6 grams, divided by the mass of the whole compound, which is 300 grams, and then multiplied by 100. So when we do 222.6 divided by 300, we get, and then of course times multiplied by 100 to put it into percentage form, we've got 74.2% of this compound is sodium. And if we subtracted that from 100, we could get the answer for oxygen, but I'm going to go ahead and set it up directly from the mass data given. So 77.4 grams of this compound is oxygen. The total mass of the compound is 300 multiplied by 100 to put it into percent form. So 77.4 divided by 300 times 100 is 25.8% oxygen. And those two numbers should add up to 100 or very close to it. There might be some subtle rounding differences, but that is a pretty good confirmation that our math is correct there. All right, we'll see a similar problem in our example number 2. What is the percent composition of the compound formed when 2.70 grams of aluminum, so that's an element, combines with oxygen, that's another element, but they're not giving us the mass of that element, and they are giving us the mass of the compound, right? So we have element plus element turning into a compound. By the law of conservation of mass, we can still figure this out. We know the mass of the compound aluminum oxide is 5.10 grams. We know the mass of one of the elements, aluminum, 2.70 grams, that's for our aluminum. And what we don't know is the mass of the oxygen. Okay, but we can subtract to figure that out. So if our mass of our compound is 5.10, and we'll subtract out the mass of the aluminum at 2.7, we know that this number has to be 2.40 grams. okay, maintaining sig figs. All right, so once you have used law of conservation of mass, you can then set up the percent composition. We have two elements, percent aluminum and percent oxygen. Aluminum is 2.70 grams over the total compound mass of 5.10 grams times 100. I'm going to go ahead and set up my oxygen setup. The mass of the oxygen is 2.40 grams. The mass of the compound is 5.10 grams. Okay, and I forgot to mention in the first problem that grams over grams cancels. So your final unit for these is just percentage. There is no grams in the final answer here. So doing the math for aluminum, 2.7 divided by 5.10, multiplied by 100, and we're going to get 52.9%. And let's go ahead and label that as aluminum so we're keeping track of which element is which. 2.4 divided by 5.1 times 100. So I get 47.1% oxygen. So there is my percent composition for that compound. So these two problems were when the mass of the elements and or the compounds in have been given to you and the chemical formula has not been given to you. So let's take a look at other types of problems that you're going to see where a formula is given. The chemical formula is given. So for example, we have propane, C3H8. It is a fuel commonly used in gas grills. It's one of the lighter compounds obtained from petroleum. Calculate the percent composition of the elements in propane. So when you only have a chemical formula given to you and no masses are given to you, you're going to have to use molar masses from the periodic table. Okay, so let's take a look at that. You still want to set this up. We have two elements, carbon and hydrogen, so percent carbon, percent hydrogen. And so what we have to notice here is there's 3 carbons, and each carbon from the periodic table to the nearest 10th is 12.1. No, 12.0. What am I thinking? 12.0. Yeah, 12.0. And then there are 8 hydrogens, and each hydrogen to 3 significant figures is 1.01. Okay. And so if we add all that up together, so 3 times 12 is going to be 36, plus another 8.08. This whole thing is going to add up to 44 and we round it, it'd be 44.1. Okay. So that's going to give us the mass of our carbon, that's going to give us the mass of our hydrogen, and that's going to be the mass of the compound. So let's set it up here. The mass of the carbon, 3 times 12 is 36.0 grams. The mass of the whole compound, 44.1 grams, multiplied by 100. When we do that, we get 36 divided by 44.1 times 100. We get 81.6% carbon. Hydrogen, the 8 hydrogens, each at 1.01, is 8.08 grams. Divided by the mass of the whole compound, 44.1 grams, multiplied by 100. The grams always cancel here. 8.08 divided by 44.1 times 100. We're going to get to the nearest 10th, or 3 sig figs, 18.3% hydrogen. This adds up to 99.9, but that's close enough. There's some rounding differences that happens, but that's how you do the problems when you're not given masses, but you're only given a chemical formula. Okay, let's take a look at one more example here. Again, masses are not being given to you, just a chemical formula. And so notice that in this problem, I'm asking you to find the percent of nitrogen and the percent of phosphorus. So there's actually 4 elements here. There's nitrogen, there's hydrogen, there's phosphorus, and there's oxygen. So this could be a problem where you're calculating 4% compositions, but in this case, we're just asking you to calculate the mass of the percent by mass of nitrogen and the percent by mass of phosphorus. Saves us a little bit of work, I suppose. We still need to know the mass of the whole thing, right? So, because we need the mass of the compound. So let's take a look at here. The molar mass, 3 nitrogens. Each nitrogen is 14.0. All right, so let's take a look at that. So 3 times 14 is going to give you 42.0. That's the mass of just the nitrogen. Okay. There are 12 hydrogens, so 12 times 1.01. So that's 12.12. That's your hydrogen. Phosphorus, there's 1 phosphorus. And I believe phosphorus, if we take a look at this one, rounded to the nearest tenth, this is 31.0. And oxygen, there are 4 oxygens. Each oxygen to the nearest tenth is 16.0. So that's 64, and that's for the oxygen. Okay, so we have to add all these up. There's the nitrogen, there's the hydrogen, there's the phosphorus, and there is the oxygen. So 42 plus 12.12 plus 31 plus 64. So this right here, 49.1, or 149.1, is the mass of the entire compound. Okay. If we set up the problem for phosphorus, the 1 phosphorus was 31.0 grams, divided by the mass of the whole compound, 149.1 grams, multiplied by 100. So let's do the math here. I'm going back up to nitrogen. 42 divided by 149.1 and multiplied by 100, and you're going to get 28.2% nitrogen. And the phosphorus is 31 divided by 149.1 times 100, and we get 20.8% phosphorus. Now those two will not add up to 100% because we did not calculate the percent of hydrogen, nor did we calculate the percent of oxygen. We could, but the question only asked us to find the percent of nitrogen and the percent of phosphorus. All right, so that's how you do percent composition problems. There should be a problem set ready for you to try on your own. And thanks for tuning in. I'll see you back in the classroom.